Okay, so as in the last video, we have done MCQs from Punjab board textbook. Today we are going to solve the MCQs from the Federal Board textbook. So let's start with the first one, what they are asking us in this MCQ, right? So they are asking for which species Bohr's theory does not apply. It is the same as we have in our previous question answers. We were having this MCQ in our Sindh board book as well as in Punjab textbook, right? So in federal this is also present, right? So for which species Bohr theory does not apply? We know that Bohr's atomic theory is only applicable for the monoelectron species. Hydrogen has a one electron, which means it is a monoelectron species, right? Wait, I don't know what happened. Okay, no worries. So helium plus, which means it has lost one electron, so it is applicable on helium plus as well. Lithium plus 2, which means it is applicable on lithium plus 2 as well. Since it has lost 2 electrons, now only 1 electron is left, so it is also a monoelectron species. Beryllium has, you know what, hydrogen, helium, lithium, beryllium have 4 electrons and it has not lost any of them, so which means it has 4 electrons present in it, which means Bohr atomic model is not applicable to the beryllium, right? It is not applicable to beryllium. Okay, so now we have from from the discharge tube experiment, it is concluded that mass of a proton is in fraction. No, of course, by a discharge tube experiment we didn't conclude that we have, the mass of the proton is in fraction. Second, matter contained electrons. Yeah, this can be a correct option. Let's read the third and fourth first, then we're going to conclude which is the correct one. Third says nucleus contains positive charge. Yes, nucleus contain positive charge, but it was not said or it was not concluded by discharge tube experiment, right? It wasn't basically concluded. It was concluded by, Rutherford experiment. Rutherford alpha particle scattering experiment concluded that nucleus has a positive charge, or nucleus contain a very heavy particle, which he termed as proton. Yeah, positive rays, right? So third and fourth cannot be the answers as well, which means our B is the correct option. Matter contained electrons, right? So matter contained electrons. Now, what the third option or third question asks us about: when an electron of charge E and mass m moves with velocity v around the nuclear charge Ze in the circular orbit of radius, the potential energy of electron is given by. They have given us basically mass, they have given us charge, they have given us velocity, they are asking us about the potential energy, and we have basically driven the entire equations for the, the potential energies, right? We have calculated the total energy as well, we calculated kinetic energy of the electron as well, we calculated everything, right? We have discussed this chapter in very, very, very detail. So the potential energy was given by basically Ze square by r. Alright, so let's see where it is. Ze square by r. So basically it is minus Ze square by r, because in, the potential energy we take the charges with their signs, right? So we know that we have one electron and it will going to have negative charge, then proton it will going to have positive charge, right? So that's why minus Ze square by r. So this is the correct option, right? Now what does fourth MCQs ask us about? Which of the following tell about shells of an atom? We have already discussed, we have 4 quantum numbers, right? Let me write this here. 4 quantum numbers. How many? We have 4 quantum numbers, right? First one is about, you know what, the principal quantum number. Quantum number which is represented by n, and it tells us about the shells, right? It does tell us about shells. Shells. Then we have azimuthal quantum number. Azimuthal quantum number. And what does it tell us about? It tells us about basically the subshell, right? SPDF, right? Then we have third quantum number. And the third quantum number is magnetic quantum number. Magnetic quantum number. And it does tell us about orbitals, right? Orbitals or orientations, right? And then we have fourth quantum number. This is spin quantum number, and it tells us about the spinning of an electron, right? Spinning of an electron. Alright, so principal quantum number tell us about the shells. So let's see which of the following tell about shells of an electron. We know that principal quantum number tell us about the shells of an electron. So let's mark this, because this is the correct option, right? Principal quantum number. And now what is the fifth MCQs and what does it ask us about? Electronic configuration of a species M plus 2 is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, and its atomic weight is 56 number of neutron in the nucleus of the species. Basically, they have given us atomic weight, which is atomic mass, right? They had given us electronic configuration as well. What we need to find is, we need to find the neutron number which are present in the nucleus of an atom. Alright, so let's find the electrons first, because we know that atomic mass is basically the sum of neutron as well as the electrons, not electrons, however protons, and electron number is equal to the proton number. By electronic configuration, we can actually get the proton number, right? And then that proton number we can subtract from the atomic mass, and we can get actually atomic, not atomic, however, neutrons which are present in the atom, right? So 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 6, 24, and 2 have been lost. So 26 plus 2 is 28, right? So 28, actually I just added this wrong. 2 plus 2, 4, 4 and 6, 10, 10 and 2, 12, 12 and 6, 18. Okay, so we have basically got here, the 26. When we're gonna subtract this 26 from 56, we're gonna get 30. Alright, we're gonna get is 30. So our correct option is 30. Our correct option is 30. Right? So now what our 6 MCQs ask us about? The energy of an electromagnetic radiation is 3 into 10 to the power minus 12 ergs. What is the wavelength in nanometer? We basically know that for energy, for wavelength energy is basically given to us energy is basically given to us, and what energy is given to us is 3 into 10 to the power minus 12. 3 into 10 to the power minus 12 ergs. They have given us ergs, right? And we know that 1 erg is equal to 10 power minus 7 joules. All right, and we know the formula for the calculating the wavelength as well. E is equal to hc by lambda, right? E is equal to hc by lambda, right? We need to calculate the lambda, so lambda will be equal to hc by E. Now we can put the values and we can take the answer. Here I am directly going with the answer, and the answer is nothing but it is 662.5. all right. Okay, so now what does our 7th MCQs ask us about? Which of the following configuration is not correct according to the Hertz rule, right? Hertz rule tell us when P orbital or D or F, but here we have only till P, right? So whenever P orbitals starts, we need to give one electron to every, right? So you know what, this is completed. Here we don't have to see, we need to look to the P1, right? Initially they have given us one electron, then they have started given it second electron. Now electrons are ended, which means this is correct, right? Now if I see this, right, they have given us one electron, which means there were only 2 electrons in the P, so this is correct as well. All right, if I do see this third one, they have given us one electron, but they don't have given one electron to this. However, they have given one electron to directly this, which means this is wrong. So our correct option is this, of course. So this is the correct option, right? So now 8 MCQs. Which one of the following statement is not correct? Rydberg constant and wave number have same unit. Of course they have same unit. They have asked us about not correct, right? Which means which statement is wrong from these. So Rydberg constant and wave number, they both have same unit, which is meter inverse. Lyman series of hydrogen spectrum occurs in an ultraviolet region. Of course this is correct as well. When we were discussing about hydrogen spectrum line series, right, we have discussed about Lyman series, Balmer series, Preston series, Brackett series, Fund series and Humphrey series, right? Third option, the angular momentum of the electron in the ground state of hydrogen atom is equal to h by 2 pi. Yes, this is correct as well. We basically said that according to the quantization condition, electron will only going to revolve in that orbit in which its angular momentum will be integral multiple of h by 2 pi, which means it is in first orbit, and 1 h by 2 pi, which means h by 2 pi. So yes, this is correct. The D option says the radius of first Bohr orbit of hydrogen atom is 2.116 into 10 to the power 8 centimeter, which is of course wrong, right? We know that is 0.529 Armstrong. So what is incorrect here? We have fourth option incorrect. Incorrect, right? Now what 9 asks us about? Which one of the following is not isoelectronic species? This MCQ we had in our the Sindh board textbook as well, I guess in Punjab board textbook as well, which we solved yesterday, right? So Mg minus 2 PE, this you can actually solve by yourself. Now I'm not gonna solve this since our video is going very long now, right? So I'm just going through the last one. The third line in Balmer series corresponds to an electronic transfer between which Bohr orbit in hydrogen. They have asked us about third line of Balmer series, and Balmer is the second one, which means electron from anywhere comes to the second orbit. So initially electron will be coming from the third to the second, that is the first. Electron from the fourth will be coming to the second, that would be the second line of Balmer series. Then electron from the fifth will be coming to the second orbit, and that would be the third line of Balmer series, which means electron from the fifth is coming to the third one. So this is the correct option. So here we have completed our federal board textbook MCQs as well. In the next video, we will be trying to complete the MCQs from OETP, the NUST past papers guidebook, and we will be trying to complete the MCQs from the KPK textbook as well. So this was all for today.